All right, let's talk about the absolute value function. This is the notation. F of x is equal to the absolute value of x. So what does this mean? What does the absolute value function give you? Well, it always gives you a non-negative number. So for example, the absolute value of 5, what? Just gives you 5 back. The absolute value of 0 just gives you 0 back. Now, the absolute value of minus 5, though, what is that? It gives you a minus 5, or equivalently a plus 5. Okay, so anytime you stick in a negative number, you get a positive number out. That is its minus. Remember, just because you see a minus x doesn't mean it's necessarily negative. So what does the absolute value function really look like? Well, it's a piecewise defined function. The absolute value of x just gives you x when x is greater than or equal to 0. Just gives you the same number you put in. But if x is less than 0, it gives you the negative of that, as in minus that. So let's verify that in fact that's the rule that's happening. So again, if I stick in a 5, that 5 is greater than or equal to 0. I just get the same thing back, so I just get 5 back. But if I stick in a minus 5, then since minus 5 is less than 0, what I get out is minus a minus 5. And what is minus a minus 5? The answer is 5. And isn't that the value you get out? The absolute value of minus 5 is 5. All right, so how would one graph this piecewise defined function? And the answer is you have to break it up into two parts. One part is when x is greater than or equal to 0. And that equation is just y equals x. So on the positive arm of the x-axis, we just graph y equals x. And we should recognize that as what? Just a straight line that begins at the origin. And now, when x is less than 0, when x is negative, what does this absolute value of x look like? It looks like minus x. If you look at y equals minus x, what is that? Well, that's also a line, but that's a line with negative slope. It's got slope minus 1, so that's going that way. So when we evaluate the function y is equal to the absolute value of x, it really is two line segments stuck together. Now let's think about this function with a vertical translation. Kind of a review from the previous section. So we know what our function y is equal to the absolute value of x looks like. We just did that above. And it looks like that. So what about this new function, y is equal to the absolute value of x plus 6? What would that do? Well, you recall, all it would do is take this graph here and move it up 6 spaces. And that's just a little review of vertical translations. Now let's talk about evaluating absolute value equations that are a little more complicated. So let's suppose g of x is x minus 1 add 3. That's our function. Rather, the absolute value of x minus 1 add 3. Then what would g of 0 be? Well, I just plug in 0. I get the absolute value of 0 minus 1 add 3. Or, if I simplify the inside, the absolute value of minus 1 add 3, which is 1 add 3, or 4. So g of 0 gives me a value of 4. Another example, what would g of 1 be? Well, I just plug in 1 up here. I get a what? 1 minus 1 in absolute value, add 3. That's 0, add 3. I just get 3. What would g of minus 6 be? Well, g of minus 6 would be what? I plug in minus 6 here. Minus 6 minus 1, add 3. Minus 7, add 3. That is the absolute value of minus 7, add 3. And what do I get? 7 add 3, which just has a value of 10. All right, so that's the way you could plug in values on an absolute value function. Now let's talk about solving certain absolute value inequalities. So I want to solve for x. And the first equation I have is the absolute value of x equals 5. Now think about what that means. What values of x, when I stick them in the absolute value, do I get 5? Well, I claim x equals 5 will work, but also what? X equals minus 5. So if underneath here is equal to either 5 or minus 5, it works, right? So my solution would be x is 5 or x is minus 5. And I could write that solution set as the set of 5 or minus 5. All right, let's generalize that a little bit and solve this equation. The absolute value of x minus 4 equals 6. Well, how can that happen where I take the absolute value of something and get 6, and I claim it could happen two ways? One way is if x minus 4 just had the value of 6, but the other way is if x minus 4 had the value of minus 6. And that's how I get my two possible solutions. X minus 4 equals 6, or x minus 4 equals minus 6. And now I take this x minus 4 equals 6, and what? I add 4 to both sides, so I get x equals 6 plus 4, or x equals 10. The other equation, x minus 4 equals minus 6, I add 6 to both sides, or actually, I'm sorry, I add 4 to both sides, and I get x is 4 minus 6, or x is minus 2. So there are my two solutions to that equation, x equals 10 or minus 2. Now, in both of these examples, I have an absolute value here and a positive number here. I have an absolute value here and a positive number here. But in this example, number 3, I have an absolute value here, and on the other side, I don't have a positive number, I have a negative number. Now think about it. Is there any way I could have an absolute value by itself on one side equal to a negative number? The answer is no, because anytime I take an absolute value, I get something that's non-negative. So if I wanted to write the solution to that equation, it would be the solution, it would be no solution. There is no x value that's going to work. How can I write that? I can write it as braces with nothing in between. In mathematics, we have a shorthand where I take a 0 and put a slash between it. It means the same thing. We even have a name for that set of nothing, and it is called the null set. Finally, for fun, let's do one more equation. Solve for x, the absolute value of x minus 2, add 2 equals 5. What do? Well, I get the absolute value on one side, and I take everything else to the other side. So the absolute value on this side, I take this 2 over, it becomes a minus 2. And then minus 2 add 5 is a plus 3. And now I'm back solving a similar equation to what I solved recently. How can that happen? It can happen if x minus 2 is 3. So what's underneath is 3. Another way it can happen is if what's underneath the absolute value is minus 3, because then I'd be taking the absolute value of minus 3, which is also 3. So I have this equation, x minus 2 equals 3, or this equation, x minus 2 equals minus 3. So what do? Well, on this side, I add 2 to both sides. I get x is 2 plus 3, or x is 5. What do I do with this equation here? I add 2 to both sides again, and I get x is 2 minus 3. But 2 minus 3 is minus 1. So my solution set consists of 5 and minus 1. And that's all I'm going to talk about with respect to absolute value right now.